Okay, Lewis dot diagrams of structure. When I say this, I mean I'm going to use Lewis dot diagrams to actually show structure of atoms. Okay, we're going to start off with just an ionic bond. So we're going to take two very, very simple metals and nonmetals. So I'm going to use lithium and I'm going to use nitrogen. Okay, lithium is 1 plus, nitrogen is 3 minus. I know when I crisscross these things together I get Li3N. This is your stable form of the compound. That's why you do it. That's why they're combining. They want to be this. So that means you want 3 lithiums and 1 nitrogen. So here's how I'm going to take care of this. I'm going to draw out my dot structure for lithium. There's 1, and I need 3 of them. Okay, and I'm going to take my nitrogen, I'm going to draw out its dot structure as well. I know that nitrogen is 7, so that means I got 5. 1, 2, 3, 4, 5. Did them as X's on purpose. Now what I'm going to do is I'm going to take this, it's going to go, this one's going to go, and this one's going to go. When I redraw this nitrogen, let's take my nitrogen, X, 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 and I'm going to actually capture lithium's electrons. And lithium will stay nice and close to the nitrogen. So there's your L3N. That's what the structure looks like. Okay, that's for an ionic. Let's do a covalent. For covalent, I'm going to use fluorine and I'm going to use chlorine. Fluorine is 1 minus, chlorine is 1 minus. They crisscross out to be FCl. I specifically am doing easy ones of these because you don't really need to go too terribly difficult into them. Fluorine I'm going to draw out. I only need 1 fluorine and 1 chlorine. So fluorine I'm going to draw out. It's got 7 in its outer orbit. So 1, 2, 3, 4, 5, 6, 7. I specifically messed it up just to show you that in bonds it doesn't really matter how you do it. Chlorine, 7. It's going to have 1, 2, 3, 4, 5, 6, 7. I've left these spaces open here because now what I'm going to do is I'm going to shift the fluorine on top of the chlorine. There's my 1. Okay, when I draw chlorine now, there's the X. Now what you need is you need to have something to hide the bottom chlorine. Now you count. You've got 8 for fluorine, so that's stable. Fluorine's okay with that. You hide fluorine, you count, you've got 8 for chlorine. Chlorine likes that, it's stable, so that is a covalent bond. Let's do something called a diatomic. A diatomic molecule is where something will bond with itself. We actually have a list in your booklet of diatomic molecules. You've got to find it. It's close to the end of the book. It's with acids and bases. Here's your diatomic element, there's a chemical symbol, and here's the diatomic formula. We're going to do it for oxygen. I'll show you kind of how it works. So I'm going to use oxygen. So it's going to be oxygen plus oxygen. That's going to be O2 minus, O2 minus, which is going to be O2, O2. You know that cancels out to be OO, and 2 oxygens is going to write as O2. Okay, so that's what we want to call a diatomic. Bonds with itself. Drawing it out, you take 1 oxygen, and it's got 6. So 1, 2, 3, 4, 5, 6. And another oxygen. 1, 2, 3, 4, 5, 6. This one's a little tougher to draw, which is why I'm going to leave a lot more space for it. What we're going to end up doing is we're going to share these. So let's draw this oxygen, and I'm going to draw 2 here. I'm going to draw my 2 there, 2 here. Oxygen here, 2 there, 2 there, 2 there, 2 here. Where's my ruler? Eight there, 6 and these 2 is 8. So 6, 7, 8 stable. 6, 7, 8 stable. That's your structure using Lewis dot diagrams for your diatomic for O2. There you go.